All right, let's say that we want to solve x squared plus 4x minus 12 equals 0. This is what we did the other day. We factored this down. We said, oh, this breaks down to an x plus 6 times an x minus 2 equaling 0. We have to go through all the, what multiplies together give us a negative 12, yet added together gives us positive 4, and we get this. And then we take each of these pieces and set them equal to 0 and solve it. So that or x minus 2 equals 0. Move your 6 over. You get negative 6 is one solution and 2 is the other. Now, we need to know how to do that. However, we can actually do this problem if we have Desmos extremely quickly and easily. So let's say we come to Desmos. All we have to do is put the equation in, and let's see what happens. So we're going to put x squared. Now, you can go to the keyboard and do squaring. Notice what I'm going to put. I just put xx, because what is x times x? X squared. But you can do what you like. Or x. Look at the picture forming. And then we had minus 12. Now look at the picture. Notice that right here, where it crosses at a height of 0, that's why we have it set equal to 0. At a height of 0, it has an x value of negative 6 and an x value of what? 2. Those were our solutions back here, weren't they? Yes. So we can graph it. And then, boom, where it crosses the x-axis, which is a height of 0 for y, those are going to be your solutions. So you could graph every one of these and simply very quickly see your answer. Now, we don't want that because that's not going to always happen. But if I'm doing an SOL or I need to do it or it's something that's complicated to where maybe it doesn't factor to something pretty, maybe it crosses at 1.5 and negative 3.2, well, graphing will be much better because you won't be able to do this. You'd have to use what's called the quadratic formula and solve it, but we're not doing that. Now, let's say that they give us a picture. So here's the picture. We graph something and here it is. So what do we know if we see this graph? Well, I know this. I know there's a solution right here at 1 and a solution when x is 3. There's a solution when x is 1 or when x is 3 to whatever the equation is. Now, could we create an equation? Well, we know the equation was maybe when it says equals 0 because we're looking for when this is at a height of 0. And I need one of the solutions to be 1. Well, what if I just do this? Would that not create a solution? 1 minus 1, that'd give me 0. And my other guy could be, well, I want it to be 3, so let's just go x minus 3. Boom, x minus 1 times an x minus 3 equaling 0. That equation would cross at those two spots of 1 and 3 because 1 and 3 are solutions there. Now, you could go ahead and multiply it through if you want to get really crazy and say, hey, that guy, this equation is that parabola there or close to it. Okay? They might have had some number out in front that changes a little bit, but it still is going to cross in the same spot. It just might make it a little bit steeper or maybe a little bit wider, but that's not for us right now. So what about this guy? Okay, it's a parabola. So we know it has solutions when x is negative 1 and when x is what? Positive 3. So we know whatever we're graphing, and we have it set equal to 0, a height of 0, negative 1 will be a solution, 3 will be a solution. Well, could we create some equation for it? Sure. X plus 1, would that not create if x is a negative 1, negative 1 plus 1? That would end up making it come out to equal 0. And the other piece would be simply x minus a 3. Now, again, we could distribute everything through if we wanted. We don't have to, and most of the problems won't ask us to. But that equation right there would be crossing right there and right there. That might be the actual equation that I graphed. Very simple things. The nice thing is all you have to do, if you need to, you take the equation, graph it on Desmos. It's going to always be a parabola, and you just look where it crosses the x-axis, and that will be your solutions for when it is set equal to 0.